So this next video is covering another application of derivatives, which are minimums and maximums. And this is one of the major applications of derivatives because they're gonna help us actually graph functions. So first I'm gonna start with a small definition, some definition. So we say that f of x has an absolute so keyword is absolute max at x is equal to c. So c is just some point within the function at x is equal to c if f of x is less than or equal to f of c for every x in the domain of the function we're working in the function we're working in. So next statement is we say that f of x has a relative maximum at x is equal to c. So once again, c is just some point in within the function. If f of x is less than or equal to f of c for every x in some open interval. And this open interval is around the point x equals c. The third statement, we say that f of x has an absolute minimum, so absolute minimum at x is equal to c if f of x is greater than or equal to f of c for every x in the domain we're working on. So the domain we're working on is the domain of the function f of x. So statement 4, we say that, I'm going to move this picture onto the next page. We say that f of x has a relative minimum at x is equal to c if f of x is greater than or equal to f of c for within an interval for every x in an open interval. And we're gonna term this open interval around x is equal to c. So these are just the definitions of absolute max, absolute min, relative max, and relative minimums. So we can just simply call these the extrema of the function. We don't need to, these are just the definition, because there's always gonna be the highest point. The absolute max represents the highest point of a function, and the absolute minimum represents the lowest point of a function, and the relative max and mins represent the tiny high points and the tiny low points within a function over a certain domain. So something to actually represent this definition is this picture that I had before. So this picture right here, this picture represents all of these definitions right here. So you see that there is absolute maxes and absolute minimums. So this function, the highest point is right here. So it's labeled absolute max, and its lowest point is right here, and it's labeled absolute minimum. And there are relative maximums. There are many maximum and minimums within the function. So there's relative max here, relative min here. So this is how to basically diagram. This is a visual way to see these definitions of absolute max, relative max, absolute minimums, and relative minimums. So let's actually apply this definition to a problem. So identify the absolute, so the relative extrema we do calculate, but it's usually the absolute minimum and maximum that we take into account. But in this question, we're going to look for both the absolute extrema and the relative extrema of a certain function. So let's do f of x is equal to x squared. And let's make the domain -1, 2. So includes the domain from -1 all the way to +2. So first thing we're going to do is just draw a quick sketch of this function. So we know it starts from -1, ends at 2. Ends at 2. Let me make this a little bigger. And 2. So we know that we just plug in values. So when x is equal to -1, x squared is equal to 1. So the point 1, we have this point right here. When x is equal to 1, the value of x squared is equal to 1. When x is equal to 0, the value of x squared is equal to 0. When the value of when you plug in 2, when x is equal to 2, the value of x squared is equal to 4. So we're gonna make this a little bigger. 4, let's say it's up here, and 4. Now we can draw out the function. So that's the function we're given within that domain. And what we can see here is that since now that we have a little sketch, now we can see where the maximums and the minimums are located. So we see that there is an obvious minimum at x is equal to 0. So we can say that this is an absolute minimum. And we see that there's an obvious maximum at x is equal to 2. So absolute max. So, and that those are the only maxes and minimums in this function. This point right here is not a minimum or a maximum, because this is just an endpoint of the function. This is just an endpoint of a function and is not even a relative maximum because of that. So the function doesn't have any relative maximum, but it does have an absolute max and an absolute minimum. So we can just write that here. The absolute max is equal to x is equal to 2. Absolute minimum is equal to x is equal to 0. And that's our final answer for this question. Now another question we could do is actually try to find the absolute extrema, absolute and relative extrema of the entire function of x squared with its full domain. So we can start doing that now. So number 3, I'm just going to copy the same question. So we're going to be finding the absolute and relative extrema of f of x is equal to x squared. Once again, now we have to draw a quick sketch. We can draw a quick sketch of f of x is equal to x squared. So we know we'll draw a couple of points. So we already know that at 0, at x is equal to 0, f of x is equal to 0. At x is equal to 1, f of x is equal to 1. So let me use purple. 1, 2. So at 1, the function is equal to 1. At -1, the function is also equal to 1. At 2, the function is equal to 4. And at -2, the function is also equal to 4. So we can just draw this out. Alright, and so this is just a general function of f of x is equal to x squared. And you can see that there are no obvious absolute or relative maximums of this function, because this function's domain is from -infinity to infinity. So it keeps on going it keeps on going upwards. So you see that as this function approaches positive infinity, as it approaches positive infinity, it keeps going to positive infinity. So there's no there's no obvious maximum that we can determine. And when this function approaches negative infinity, it continues to approach negative infinity as well. So we still don't have an obvious maximum from either side of the function. But what we do have is a obvious and absolute minimum at x is equal to 0. So at x is equal to 0, we have an absolute minimum value of 0. So that's what we could write. So no, we don't have any absolute max. And for absolute minimums, we have x